Okay, so let's start doing stuff with polynomials. The first thing that we're going to look at is adding and subtracting polynomials. In order to do this section, you want to be able to know how to identify and combine like terms. You also need to understand the rules for distributing a negative. Upon completing this presentation, you'll be to add and subtract polynomials involving one variable, as well as add and subtract polynomials involving multiple or several variables. Our procedure in order to be able to add and subtract polynomials is we want to start by clearing the parentheses. If adding, the parentheses are just grouping symbols and have no special significance in terms of solving the problem. If subtracting, we do need to distribute the negative to all terms in the second set of parentheses. Our next step is going to be combine like terms. Recall that like terms are terms that contain the same variables raised to the same powers, meaning everything but the coefficient must be exactly the same. Now, one thing to note when we do this section is technically we've already done this. We've already talked about simplifying expressions. And so basically all we're going to do is expand the rules that we've used in the past in order to do this. The main thing to keep in mind is that we do need to remember that we cannot combine x squared with x cubed. We cannot combine x's with y's. We cannot combine variables with constant terms. As long as you know that, then this is no different than what we've done before. We're just going to do it on a little bit larger of a scale. Now, one thing to note, there is no limit to how many terms a polynomial can have. If you are having trouble finding like terms when the problem is written horizontally from side to side, you may want to add or subtract vertically. When lining up polynomials vertically, make sure that you line up your like terms into columns. We'll see an example of this when we get into some of the more challenging examples. But let's go ahead and look at some examples now. Okay, for example A, we have negative 9x cubed plus 7x squared minus 5x plus 3 will be our first polynomial. Our second polynomial will be 13x cubed plus 2x squared minus 8x minus 6. And so we want to go ahead and first off note that since this is an addition problem, these parentheses have no special meaning. So you can either rewrite the problem without them, or you can just choose to ignore them. I'm going to go ahead and choose to ignore them, and so I'm going to go ahead and start by identifying and combining like terms. So the first thing that we have is I have negative 9x cubed. Do I have any other x cubed terms that I can combine with negative 9x cubed? We do. We have 13x cubed. So just like we did before, I'm going to add my numbers, negative 9 and 13 combined to 4. I keep my variable, I keep my exponent. Our second term that we have, I'm going to go ahead and cross these out now that we're done with them, that way we don't have to worry about them again. My next one that I have is 7x squared. I can combine that with 2x squared since they are both x squared terms. So again, I want to add my numbers. 7 plus 2 is 9. I keep my variable. I keep my exponent. We're done with those now. My next term is negative 5x, and I can combine that with negative 8x. So we want to add our numbers or combine our numbers. Negative 5 and negative 8 will combine to negative 13 since they are same signs. Remember that we add and keep the sign, and we keep the variable. So we're done with those. And finally, we have plus 3 and negative 6. If we combine those, we get negative 3. We have different signs. Remember that we are going to subtract and keep the sign of the larger number. And so we are done. This is our final answer. Our final answer is 4x cubed plus 9x squared minus 13x minus 3. We cannot go any further because you cannot combine x cubed with anything but x cubed. You cannot combine x squared with anything but x squared. Similarly for the x's and the constant terms. And so this problem is completed. All right, let's move on to example B. Example B, one of the first things to note is this is a subtraction problem. And so for this one, our parentheses in the first set, those ones are not significant to solving the problem, but the second set is. And so what we need to do is we need to start by distributing the negative. So my first step, I'm going to just go ahead and bring down my first polynomial. I'm going to discard the parentheses because, as I said, the parentheses are not important. For my second set, I do want to distribute the negative. So if we want to minus 4x squared, well, that's just going to be minus 4x squared. If I want to subtract minus 6x, this becomes plus 6x. And if I want to subtract negative 7, that becomes plus 7. So now that we have no parentheses in our problem, we can go ahead and combine our like terms. So we can combine 7x squared and negative 4x squared. 7 minus 4 is 3. We keep our variable. We keep our exponent. And so we are done with those ones. For my next one, I can combine 3x and 6x, giving me 3 plus 6 is 9, and we keep the x. And for my last one, we can combine negative 4 and positive 7. Negative 4 and positive 7 combine to give us plus 3. And so our final answer is 3x squared plus 9x plus 3. That's as far as we can take it, and so we're done with this problem. All right, let's look at example C now. And I'm going to show you another way that you can do this. Now, this is, again, it doesn't matter how you do this as long as you come up with the answer, as long as it makes sense to you. So what the first thing that I'm going to do is, again, for this problem, we do have a subtraction. I am going to have to distribute it to all of these terms. But I want to show you the vertical method. And so the vertical method, what I'm going to do is start by writing out my first polynomial. So we have 8y cubed minus 10y squared minus 14y minus 2. Now, when I do this with a subtraction, I always choose to distribute my negative first before putting my terms underneath. So for instance, on this one, I want to distribute negative to negative 5y cubed. That's going to become a positive 5y cubed. And I'm going to put it under the 8y cubed since they are like terms. I also want to subtract negative 3y. This will become positive 3y. And where do I want to put it? Well, since it's not a y squared, it's a y, I'm going to put it underneath the 14y. Again, remember that when we do this vertically, we want to line up our like terms. So we want y's on top of y's. And finally, minus 6. Since it is a constant, I'm going to put it underneath the constant. And if you've already distributed your negative, then basically all we're doing now is we are adding the polynomials. We are adding the like terms. And so if you distribute before you line it up vertically, then you don't have to worry about distributing when you start doing your operations going down. All we're doing is adding going straight down. So if we add straight down, we get 8 plus 5 is 13y cubed. I'm going to bring down my negative 10y squared. It has nothing to combine with. Negative 14 and positive 3 give me negative 11y. Because they have different signs, we're going to subtract, keep the sign. And then negative 2 and negative 6 combine to give me negative 8. Same signs, we add and keep the sign. And so one of the benefits to doing this vertically is that you don't have to sit there and search for your like terms. They're already grouped together. Okay, so that takes care of some examples involving polynomials in one variable. Let's go ahead and look at some that involve polynomials involving several variables. So if we look at these examples, depending on how you want to organize this, it doesn't really matter. If we look at example D, the important thing to keep in mind is everything after the coefficient has to be exactly the same. So note that in example D, we are talking addition, so if you want, you can choose to ignore the parentheses, and we're just going to combine like terms. So the first terms that I'm going to combine are my negative 8x squared y. I can combine that with 10x squared y. If we add negative 8 and 10, I get 2. And then I want to keep my variables and my exponents the same. Basically, whatever was to the right of the number stays to the right of the number. My next one that I can combine is negative 3xy can combine with 5xy. We do have different signs, so we are going to subtract. We get 2. Keep the sign of the larger number. And then keep our variables exactly the same. And then finally, we have the constant term 6 and negative 10 combine to give us negative 4. Different signs, subtract, keep the sign of the larger number. So our final answer is 2x squared y plus 2xy minus 4. Okay, for the last example, note that we are subtracting. So we do need to distribute the negative. Also, I'm going to do this one vertically again, just so that you have another example that you can look at in terms of how to set up the problem. So the first thing I'm going to do is rewrite the first polynomial again. So I have 7x cubed minus 10x squared y plus 2xy squared minus 5. When I distribute my negative, I get minus 4x cubed. That will go underneath 7x cubed. I get minus negative 12x squared y becomes plus 12x squared y. I get minus negative 3xy squared becomes plus 3xy squared, and it will go under the 2xy squared. And finally, I have minus 5. And now we can go ahead and add straight down. So we get 7 minus 4 is 3. Keep our x cubed. Negative 10 and 12 become positive 2. Keep the x squared y. 2 and 3 combine to give me 5. Keep the xy squared. And negative 5 and negative 5 become negative 10. And you're done. Now, can we combine those two middle terms? Can we combine 2x squared y and 5xy squared? And the answer is no, because one of them has an x squared term, the other one has an x term. The first one has a y term, the second one has a y squared term. These are not considered like terms because they are not exactly the same after the coefficient. Okay, so that takes care of example D and E, and that takes care of adding and subtracting polynomials. One of the things, once we get into other operations, make sure that you are careful that you're able to recognize when we're talking adding, when we're talking subtracting, and when we're talking multiplying. And the difference is that if there is an addition sign in between these two things, we are talking adding. If there is a subtraction sign, we are talking subtraction. And if there is nothing in between the two sets of parentheses, then we are talking multiplication. So when will we see this again? We will revisit this topic again when we talk about multiplying polynomials and combining like terms. We will also expand the concept when we talk about adding and subtracting rational expressions. And in future math classes, you will revisit and expand the concepts when you discuss operations with functions and composition of functions. I know we haven't talked about functions, but just so you know, this will come up later when you get into Math 120. So now take a few minutes, try the following problems on your own, and bring your solutions to class, as well as any questions that you have. Take a moment and pause the presentation at this point, and as soon as you are done with these problems, then go ahead and move on to the next slide. So now that you've watched the presentation and you've tried some problems on your own, please answer the following questions. How confident are you with the material presented in this section? What from this section needs to be explained further? How much more practice do you need to be comfortable with the topic?